Now if I want to make negative clipping circuit, what we need to do? Just reverse the diode, that's it. So that is the next circuit, the fourth one in this shunt clipper. So resistor R. Now if I reverse the diode polarities like this, then I can have the V reference. So I'm taking directly some value. Suppose if I take 2.5 volt, this is the VI. I am giving a sinusoidal voltage T and so on. This is the VI. So here I am giving 10 volt minus 10 volt, right? So plus minus V0, right? So this is, I am giving the name first, that is it will do the negative clipping. So negative clipper, right? And it is a biased, so biased negative clipper or negative shunt clipper, or we can say negative shunt clipper, negative shunt clipper with positive reference voltage. This is also we can give the name. Okay, now how to perform the analysis? So the same approach. If the diode D is ideal, then first condition, VA greater than VK, D, the diode D will be on. But what is VA? See here. So this is the anode. So VA is connected to V reference. So VA is V reference. VK is now VA. So V reference is greater than VA. That means VA less than V reference. What is V reference? We have taken 2.5 volt. When VA is less than 2.5 volts, the diode D will be on and it will be replaced by a short circuit. So the circuit will become like this. This is R, this is short circuit, this is 2.5 volt, this is, so this is the VI. So VI is less than 2.5 volt. This is a common point. This is V0. Now what is, tell me what is V0? 2.5 volt. Now what is the second condition? Opposite. When VI is greater than 2.5 volt, that means the diode D will be off. When it is off, see this circuit. When it is off, this path will be gone. So simply V0 is equal to VI. That's it. This is V0. Now I will draw the output waveform. This is 10 volt minus 10 VI. Now tell me what is the reference value now? 2.5. So this is positive, so 2.5 volt. So this is a V0. Now the first condition is what? When VI is less than 2.5, what is V0? 2.5. So less than means these portions, this portion. So less than means 2.5. So it will be 2.5. Here also 2.5. Now when VI is greater than 2.5, what is V0? VI. So it allows the positive portion. So something like this and so on. This is what? 2.5. And what is the maximum value? This is 10 volts, 2.5 volts. Now it is clipping of the negative portion. So what is the name of this clipper? Simply negative clipper. Or if I want to give the full name, biased negative shunt clipper, or we can say negative shunt clipper with a positive reference voltage, etc. Right? If the reference voltage is negative, so what is the waveform we will get? We will see. That is the fifth one. This is R. This is the diode. If the reference voltage is, suppose same, I will take minus 2.5 volt. This is the VI, the same signal, minus 10 to plus 10. This is V0. Right? Now the same approach. What is VA? Now see, it is connected to, this is ground, minus 2.5. And what is Vk? It is Vi only. So ideal case, okay. First condition, Va should be greater than Vk, that is minus 2.5 should be greater than Va. That means what? When Va is less than minus 2.5 volt, the diode D will be on. When it is on, short circuit. Or short circuit, this is 2.5 volt. This is Vi but less than minus 2.5 volt. This is V0. Now tell me what is V0? Whatever the voltage is here, that is minus 2.5 volt. Now what is the second condition? Very simple. When Vi is greater than minus 2.5 volt, the diode D will be off. Why? See, anode voltage is minus 2.5 volt. Always remember, when the diode D on means anode voltage should be greater than the cathode voltage. So that means if it is minus 2.5 volt, so that means the cathode voltage should be less than this value. So that means it should be minus 3.5 volt, minus 4.5 and so on, right? Suppose 0 volt, 1 volt, minus 0.5 volt. So the cathode voltage will be greater than this anode voltage. That means it will be off. That is the meaning of this one. When Va is greater than minus 2.5 means minus 1.5 or 0 or 1 and so on. So the diode will be off. When it is off, simply V0 is equal to Vi. Right? That's it. Now how to draw the output waveform. So this is minus 10, this is 10 volt, this is the Vi. Now what is the reference value now? Minus 2.5 volt. So this is the V0. So when Vi is greater than minus 2.5, D off, what is V0? Vi. So we'll get the like this. Now when Vi is less than minus 2.5, that is negative half cycle, what is the V0? Minus 2.5. So minus 2.5, and it is allowing like this. What is the maximum? 10. What is the minimum? Minus 2.5 volt. This is the 10 volt. Now still it is negative clipping only. So negative shunt clipper with negative reference voltage or biased negative shunt clipper, right? Both are same. So this is when the diode D is ideal. So we are discussing about the negative clippers. So we started the when the diode D is ideal. Now we will go for the practical scenario. So that is the sixth circuit. The same circuit I have to take. R diode D is like this, and here same I will take the V reference as 2.5 volt positive, Vi, V0. Now when the diode D is practical, that means VD on is 0.7 volt, VD on 0.7 volt. Then the first condition, so Va minus Vk should be greater than at least 0.7 volt, then the diode D will be on. Now what is Va? 2.5 minus what is Vk? Vi. See here, this is the anode voltage, this is the cathode voltage. So Vk will be connected to Vi, Va is connected to 2.5, greater than 0.7. If Vi is going that side, 0.7 is coming this side, so 2.5 minus 0.7 should be greater than Vi, or Vi is less than how much? 1.8 volt. So when Vi is less than 1.8 volt, diode D will be on. It will be replaced by a 0.7 voltage drop. So now the circuit will become like this. This is R. Now see the polarities of the diode, right? So negative is top and the positive is downside. This is 0.7, this is 2.5, this is the Vi but less than 1.8 volt. This is the V0. Now tell me what is V0? Simply 1.8 only. Minus 2.5 plus 0.7 plus V naught equal to 0. See here like this, minus 2.5 plus 0.7 plus V naught equal to 0. So V naught will be 1.8 volt, right? That is the first condition. What is the second condition? Just opposite. When VA is greater than 1.8 volt, the diode D will be off. That means open circuit. So circuit will be like this, 2.5 VA. Now tell me what is V naught? Simply VA, right? Now how to draw the output waveform? So we got two conditions. First condition, when VA is less than 1.8 volt, V naught is equal to 1.8 volt only. Second condition, when VA is greater than 1.8 volt, V naught is equal to VI. So this is the 10 volt minus 10 volt. This is VA. So 1.8 volts. So only difference will get a 0.7 voltage difference only from the ideal case and the practical case. This is V naught. This is 1.8 volt. Now first condition, when VA is less than 1.8, we'll get 1.8 only. So here 1.8, here 1.8. Now this is 1.8 volt. When VA is greater than 1.8, so it is following. So that means we'll get like this. So this is what? Maximum 10 volt. If you see from the ideal case and the practical case, so what we got? So we got from 2.5 to 10. Now we are getting 1.8 to 10. The only difference is 0.7 volt, right? So again, what is this? Same, negative clipper, negative shunt clipper, and it is biased, or we can say negative shunt clipper with a positive reference voltage, right? Now the next circuit is when the diode D is practical and the V reference is suppose negative. So that is the next one, seventh circuit. Same, or now if the reference is suppose 3 volts, VI, now I am taking a square waveform, something like this. 4 volt minus 4 volt. This is VI. You do the some another question with 3 volt minus 3 volt. So that will be a good question. So that is for you. Take 3 volt minus 3 volt and do the analysis. What is the output waveform you will get, right? So I will do for 4 and minus 4. Now again, when the diode D is practical, what is VA? Minus 3 volt. What is VK? VI. So this is the VA, this is the VK. When the diode D is open, VK is connected to VA. VK is connected to VI. VA is connected to minus 3 volt. Now first condition, when VA should be greater than, my VA minus VK should be greater than 0.7 volt. VA is what? Minus 3 minus VI greater than 0.7. So minus 3 minus 0.7 greater than VA. That means when VA is less than minus 3.7 volt, the diode D will be on. So replaced by the voltage drop 0.7 volt. So the circuit will be R minus plus 0.7 minus plus 3 volt. This is the VA, and VA should be less than minus 3.7. So what is V naught? Same, minus 3.7 plus 3 plus 0.7 plus V naught is equal to 0. So V naught will become minus 3.7. So the second condition just opposite. When VI is greater than minus 3.7 volt, diode D will be off. When it is off, V naught is equal to VI. Now to draw the output waveform. Okay, I have taken the square waveform. What is this? Maximum 4 volt minus 4 volt. This is VA. Now what is the reference value now? Minus 3.7. So very closer to 4 volts. So minus 3.7 volt. This is the V0. When VA is less than minus 3.7, what is the value? Minus 3.7. So minus 3.7 here. So minus 3.7, right? Now when VI is greater than minus 3.7, diode D will be off, V0 is equal to VI. So we'll get the total positive half cycles. So maximum is 4 volt, minimum is minus 3.7. Only the clipping portion is 0.3, that also negative side. So this is the only clipping portion. So this is clipped off, right? Now what I told, if you take this is 3 volt minus 3 volt. Now tell me, is there any minus 3.7 in this waveform? No. So what is the output waveform you will get? You should get as it is. There is no change in the input signal when you take 3 volt to minus 3 volt. What is the meaning? That the diode D is continuously off. Why? This is the minus 3 volt. The maximum is 3 volt. If I take maximum here 3 volt, which one is higher, 3 volt or minus 3 volt? 3 volt. Diode D is off. Now what is the minimum? Minus 3. Now tell me, this is minus 3, this is minus 3. What is the difference? 0. Is it greater than 0.7? No. So that means the diode is always off when we give a waveform like this. Maximum 3 volt, minimum is minus 3 volt, right? So you will get always V0 is equal to V. So there is no clipping is happening. So we cannot say this is a clipper circuit when we give the input voltage from minus 3 volt to plus 3 volt. It may be sinusoidal, it may be triangular, it may be square waveform, right? So this is about the shunt clippers. You can have this battery above the diode also, right? That is something like this. The eighth one, this is resistor, or if I give a reference value 2 volts here, and here if I place a diode like this, and this is the VI, this is the VI. Now this is also a clipper V0, right? So I will do for ideal case, you can proceed for practical one, right? I can place this battery in series with the resistor also. So I mean that will give the same operation, no change at all. Okay, so that also you can try on your own. Now first we need to find V and Vk. So this is the reference point. So Vk simply 0. But what is Va? We cannot say directly Va is equal to minus 2 volt, right? So when we open the diode, something like this, so we have to apply KVL to find the Va. So it will be minus Vi, open means no current flows, plus 0 plus 2 plus Va equal to 0. So what is Va? Va is going that side, minus 2. So Va is now Vi minus 2. That means a DC voltage is added to Vi. That is something like this. Suppose if Vi is like this, 5 volt minus 5 volt. So when I add this 2, that is minus 2 actually. So the Va now will become like this. So 0 minus 2. So it will start from minus 2. So when I give 5 volt, it will become 3. So something like this we will get. So minus 2 volt is now DC. So maximum is 3. Here minimum is negative side, maximum is minus 5 minus 2 minus 7 volt. So that is the meaning of this Va is equal to Va minus 2. But we don't require this one, we can go directly. That is something like this. Now the first condition, Va should be greater than Vk, diode D will be on. What is Va? Va minus 2. What is Vk? 0. That means when Vi is greater than 2 volts, the diode D is on. When the diode D is on, what is the circuit? This is 2 volt short circuit, Vi plus minus V0. Now tell me what is V0? Simply 2 volts. Other case, when Vi is less than 2 volt, diode D will be off. That means V0 is equal to simply Va. The circuit will be like this: R 0.7, sorry, 2. It's a 2 volt open circuit. This is Vi but less than 2 volt. Now tell me what is V0? So open circuit, no current flows, so neglect this path. Simply V0 is equal to Vi. Now how to draw the output waveform? So I'll take Vi only, right? This is the Vi. Now tell me what is the reference value? 2 volt, maximum 5, minimum minus 5. Now what is the output waveform? Now first condition, when Vi is greater than 2 volts, what is V0? 2 volts. So greater than 2 volts means 2 volts only I am getting, 2 volts. So less than 2 volts, V0 is equal to Vi. So something like this. So we'll get full negative portion and some portion of the positive half cycle also. Something like this. Maximum is 2, negative side minus 5 volt. So what is the clipping circuit name? Again it is positive shunt clipper with the bias, or positive shunt clipper with a, so V reference is something like this. This is the V reference, right? So positive reference voltage with a positive reference voltage, right? So this is the circuit. So you can go for when the diode is practical, and you can reverse the polarities of the battery. That will become one more circuit, and you can place this battery here or here. But if you place this battery, same battery here, something like this, it will give the same operation. Why? Again apply KVL and find Vi. You will get same, minus Vi plus 2 plus Va equal to 0. So minus Va, anyway this is 0, plus 2 plus Va. If you reverse the polarities, so if you place here or here or here, so you will get the same operation, right? So that you can try on your own with ideal case, with practical case, etc. Right? So this is about all the shunt clipping circuits. I hope it is clear. If you are having any doubt, please post a comment. In the next lecture, I will start the clamping circuits.